So now in this video we come back to the J310 right there. It's an N-channel JFET transistor, and we looked at the IDSS in the last video. So SS meant the source was connected directly to ground instead of a resistor, and with this particular one we got 34 milliamps of current. We could have expected up to 60 milliamps and I believe down to 20 milliamps, but this particular one it's about 34 with the IDSS. So if you take that source and add resistance, the current just goes down from there. That's why it's important to know the IDSS of the particular one you're using, or you can just keep using different value resistors until you get the current you want. It's kind of just guesswork for the most part. I don't think there's any formulas anywhere. So in any case, it does not depend on load as long as you have enough supply voltage. So with the blue LED here, and the red, the two of them, we probably will need about 12 volts. Just the red LED and the transistor probably 9 volts, maybe down to 8. With the transistor alone, probably 6 volts will hold that current. So as the load goes up, its voltage demands goes up, you just need more supply voltage to be able to get the current that you set. So now I have the multimeter set to measure milliamp current, and we have about 5.75 milliamps of current there going through all three components. I have the power supply set to 12 volts. We're going to bypass the blue LED. You can see that it held pretty steady. Might go up a little bit because the transistor got a little warm or something, but for the most part it's practically the same amount of current if you consider that we just changed the load considerably. We're just doing the transistor now. So now, as I said before, the power supply is set to 12 volts. Let's lower the voltage with just the transistor, and looks like it's going down a little bit as we get closer to 4 volts. Alright, so it looks like we probably want at least 5 volts with just the transistor there. Let's get the red LED back in series there, and we'll probably see that the current dropped down a little bit. So it's still doing okay, but let's get the voltage up until we get back to our, there we go, that's pretty close, 5.75 right there. So we want at least 8 volts, probably 9 volts would be better. And then the blue LED there, again, that's going to cause some more problems. Let's get it in the right spot there. Alright, blue LED, and so we want at least 5.75. So there we go, 12 volts, that's probably about the minimum we should have, but as you can see, we had a little bit of wiggle room there. We just lost a little bit of current. Held okay. But in any case, this video has gone on long enough. So thanks for watching. Make sure you turn the multimeter off though whenever you are done, especially when you're measuring current.